Hi everyone. In this video, I will explain orchestrator-worker type of workflow in LangGraph. What exactly it means, I'll try to explain through this sample workflow image. So what happens here is that there is an orchestrator or there can be a planner agent or a node which will generate a plan in form of a list of elements, list of tasks, list of sections, anything can be there. And depending on the number of elements present in that list, those many number of times this node will be called. So if this node is generating a list of 3 elements, then this node will be called 3 times. Okay. And then once the output from all the 3 calls is generated and saved, then the final synthesizer node can be called, which can combine all these outputs, or it can do further summarization, further processing on that. So this is how a typical orchestrator worker type of workflow works. So there are a lot of important components involved in this type of workflow, which I will explain when I walk you through the code. So let's go to the notebook and see how it works. Okay. So first we will do all the necessary imports. Next, we will initialize our LLM. Here I'm using Grok API because it is free. If you want to understand how to use Grok API for free in LangChain, please click on the link in description. So we have initialized our LLM. Now we will define the structure of the output we want from from our orchestrator node. So this node will generate an output in structured format, which will have specific fields. Okay, and the output will be in form of a list. So this is the class which will go into the LLM and will make it a structured LLM, which we call it planner. And what sections will contain? It will contain a list of elements which are coming from sections class. Okay, so basically every element of a list will be a dictionary having 2 fields, name and description. What is name? Name of the section of the report, and brief overview of the main topics and concepts to be covered in this section. So basically in this example, what we are trying to do is that the user will provide a topic, and then based on that, the orchestrator agent will generate a list of sections that should be present in that report that has to be generated for the topic. And to generate the plan, it will provide the name of the topic as well as description, so that the subsequent call to LLM can understand that what this section should contain. Okay, so for that reason we want the output of orchestrator in this format. So let's run this. So our planner structured LLM is set up. Now we will define the state. So this is the state of the main graph, and this going to be the state of the worker. So this will be our worker node. Okay, so this will do task based on the dynamic plan that is generated. Sometimes it can generate only one element in the list. Sometimes it can generate 10 elements. So based on that only, this flow will decide how many times this worker has to be called. So this can have a different state, completely different from the complete flow. Okay, so this is the main state where we will save the topic coming from the user as an initial state. Okay, then sections, list of section we will capture, which will be generated by the orchestrator. Then completed sections. So basically whatever output is generated by the worker state, it will be saved here in form of a list. And we have a user reducer also, add reducer, because whatever output is generated by each call, it should be appended to this field rather than overwriting. So for that reason, we have used operator.add reducer. Okay. Next is section start time. So this I have added as a field just to demonstrate that whenever this node is called, it will always be called parallelly. Okay. So if 4 elements are created by this one, then 4 times this will be called and all the calls will be in parallel. So when we save this information that what was the start time of that call, you will see that the start time will be exactly the same for all the sections that are generated. Okay. And then the final report, which will be generated by the synthesizer. So this will be saved here. Okay. Next is the worker state. Here we will save the section which will be a dictionary of this type containing name and description. And then we will have the completed section. So completed section will be saved here also. And then whatever output is generated, it will be same thing will be saved here also in the main class also. I will show you how it works. Okay. Next is next are the nodes that we have to define. First is the orchestrator. So So the orchestrator node's task is simply to take the topic from the user input and then generate a plan for the report. And how the plan should be generated, it should be controlled by the planner LLM, which is a structured LLM. So basically, it will return a list which will contain every element of the list will contain name and description of the section. Okay, so it's very simple. It will simply contain create a list and save in the sections field. Next is the LLM call. So LLM call, what I did is that before the LLM is called in this node, we get the current time and we save it, convert it into a string format. And then this current time is also sent as an output in the section start time along with the in form of a dictionary because we are using a reducer of type dictionary. So we have to send the output also in this format. And then we will just take the section name and the current time. So when I run it, you will see that all the sections ran in parallel at the same time. And then whatever output is generated by this one. So let's see what this LLM is doing. Write a report section following the provided name and description. Include no preamble for each section. Use markdown formatting. Okay. So here we have given the section name as well as the section description, which is coming from the state, which is a type which is of type worker state. So worker state is a smaller state which is independent. It only contains these two fields, section and completed section. It does not complete the contain the complete output. Okay. So this will be controlled by a different router, which I will show you later. Okay. So once this output is generated, this information will be saved in this state also and in this state also. Okay. So here I forgot to add this field, but we can add here because it is optional. We want to add it here, we can add it. If we don't want to, then also it's okay. Okay, so then this is done. Next is a synthesizer. Synthesizer's work is very simple. It will take the completed sections, which is a list, and then simply it will take all the section and join them. That's all. It is not, there is no LLM call here involved, but we can use LLM call also if we want to summarize it or something. Then we can use LLM call. But since this is for demonstration purpose only, we will simply use Python to just combine it. Okay. And then whatever is the combined output, it will go in the final report. So this is our router function. So this is a very interesting part here, send API. So what it does is that whatever output is generated by the orchestrator. Okay, so it goes in the sections, which is a list. So here the assign worker will take the sections and whatever elements are present in this, they will all be sent to this LLM call node in parallel one by one. Okay, not one by one, in parallel. Like let's say in the section I have three elements, so three times this will be called, and then all of them will be called at the same time and sent to LLM call. So basically the input initial state for this LLM call will be this, where it will take section and it contains S, which is both the name and the description of the section. Okay, so here it will take the section field as an input. Okay, so this is very important. The send API, what it does is that it will execute or call the LLM call node parallelly, okay, for all the sections. So it will only work when we can do, when all the outputs generated are independent of each other, there is no dependency, then only this will work. Otherwise, for example, if for the third section we need output from this from the second section, then in that case we cannot use send API. We will have to do a for loop and then we will have to run it one by one so that the output from the previous runs is available to the subsequent run. So send will only work when we are running things which are independent of each other. Okay, so this is a router. Now we will just define our workflow. We initialize it using state graph. These are the nodes. Here our node is orchestrator node, LLM call node, and synthesizer node. These three nodes. And this one is a router. This is not a node, okay, which will be used in the conditional edge. Okay. Next, we define our edges. The fixed edges are from start to orchestrator, and then from LLM call to synthesizer. LLM call to synthesizer also a fixed node, fixed edge, and from synthesizer to end. That is also a fixed edge. Let's now come to the conditional edge. So conditional edge will start from orchestrator. Okay. and then it will take the router which is assigned workers. And the possible nodes that can be used here are these. So this is optional, but if we remove this, then our graph visually will not look good. So we will not be able to understand what is happening in the graph. So all these will be disconnected. Otherwise, technically the flow will work as it is. Okay, there will be no problem technically, but visually you won't be able to understand what is happening in the flow. So for that reason, we simply just tell what all nodes are possible. So if there are more than one nodes which are possible from the orchestrator based on this condition, then all the list of those nodes we can provide here. Okay. So now the flow looks more meaningful and more intuitive. What is going to happen? Okay. So now our graph is complete. Let's try to invoke it and see how the final output looks like. So the topic that we have provided is create a report on LLM scaling laws. Okay. So it is taking some time because it is calling the LLM call multiple times. Okay. So for that reason, it is taking some time. So this is the final output that is generated. But let's see what all information is saved in the complete output. That is more important to understand. If you see here, the initial topic, this was an initial state. Okay. Then these are the sections which are generated by the orchestrator. It is a list of elements, and each element contains this section type class, and it has two elements, name and description. Okay, so these are the items sections that orchestrator has generated. Then these are the completed sections. These are the outputs generated by LLM call. And this is the most interesting part. If you see here, before running LLM call each time, I tried to capture at what time it started. Okay, if you see here, I tried to capture at what time this LLM call was executed. So for every section, yeah, for every section, if you see, it started at exactly the same time. Introduction, background, scaling laws. So these are the names coming. Introduction, background, scaling laws, empirical evidence, theoretical framework. Everything started at the same time. And since we had used OR reducer, nothing got overwritten, it got appended. Okay, or it got added into the list, into the dictionary. So all send API will always do parallel execution. And then the final report, this is simply a synthesizer. It will just append it. So nothing fancy there. Okay. So now let's try to stream it also and see how it looks like. First orchestrator, then all the LLM calls. The reason it is coming one by one is that the section complete time is different for each one of them. Okay. So it started all at the same time here also, but the complete time will be different for each one of them. So that's why they come as an output one by one. And this synthesizer will be called only when all these calls are completed. Unless all this part is completed, this will not be called. So when the last one completes, only then this synthesizer will start. Okay, so that is really important. And here also I tried to show that what all sections were generated and in what order. So these were the 5 sections which are generated: introduction, background, scaling laws, applications, and conclusion. And these were the corresponding LLM calls. Okay. And here also, if you see, they all started at the same time, right? And then the final output is simply append of all these things. Okay. So yeah, so this is about orchestrator worker type of workflow in LangGraph. Please let me know in comment section what other videos or what other concepts you want to learn around LangGraph or AI. And please subscribe to my channel. Thank you for watching. Bye.